Hello, welcome to Marine Gurukul video series. We are happy to present volume 2 on tides that shall cover the tide calculations for standard port of Admiralty Tide Table volume 1 covering the European waters. We hope you have watched our earlier video titled Tide 1, which was aimed at understanding tides and understanding the layout of tide tables. If not, we recommend that you watch that video before going ahead with this one. We also need to familiarize ourselves with a couple of terms which shall be used when we engage in calculation of tides at standard ports of ATT Volume 1. The first term is the range of tide, is the difference between the height of high tide, that is high water, and height of low tide, that is low water. The difference between the heights is referred to as range of tide. Duration of tide is the interval of time between high tide and low tide. That means if the height difference is called as range of tide, the time difference is referred to as duration of tide. Interval from high water is the interval either before or after high water, as the case may be, between the time of interest, that is the time for which we are interested in the height of tide, and the time of high water, which is closest to that time. So it could be before high water or after high water. In this video, we shall be learning the calculations of tide at the standard ports in ATT Volume 1. And we know that the standard port information in the tide tables is contained in what we call as part 1 of the tide tables. Part 1 of the tide tables contains daily prediction of times and heights of high and low water at the standard ports. How this information is captured in ATT Volume 1, let's familiarize with those pages. One of the pages for part 1 shall be as what has come on the screen. On top, we'll have the name of the port and its coordinates, latitude and longitude. Then right top, we have the year for which the tide tables are made. Left top of this page, we have the time zone. That means the time zone in which the times are tabulated. So whatever time for high and low water we get from these pages, they shall be in the time zone that is stated on top. And then we see this main body of the page, which contains daily predictions of times and heights of high and low water for each day of the year. In part 1 of ATT Volume 1, for every standard port, there shall also be a curve or a diagram that shall be used for calculation of heights at times other than high and low water. So this will be the curve which shall be used for interpolation. Now for ATT Volume 1, each standard port has its own curve. So the curves are port specific for ATT Volume 1, and you have to use the curve of the port in question. The curve shall look the way it is shown on the screen. What is there on the screen is the curve for the port of Antwerp, which is a standard port of one of the standard ports of ATT Volume 1. Let's familiarize ourselves with this interpolation curve or the tide curve. Now, if you see on the x-axis of this curve at the middle, we have the high water. To the right of it, we have on the this base axis interval after high water, and you can see this interval is prefixed with plus, that means plus 1 hour, plus 2 hour, and so on. And right at the end, we have the low water here. To the left of this high water, we have interval before high water, and the intervals are prefixed with minus, and again we have high water on this side. In this diagram, this line represents the chart datum. Then we have this scale on top. This is the scale for high water heights in meters. It's written out here. And you also have mean high water neaps and mean high water spring also marked on the same scale. And likewise, at the bottom, we also have a scale which is for low water heights in meters, and you have mean low water spring and mean low water neaps also marked out here. Then out here we have something marked as mean ranges, and if you see against the spring range, which in this case is 5.5 meters, you have this bold line. That means the bold line here represents the curve for the spring range, and likewise this broken line where the neap range is 4 meters in this case, the broken line represents the curve for the neap range. Now to use this curve we shall take into account the range of tide in question. If the range of tide in question matches with the spring range, then we shall use the spring curve. We shall use the mean spring curve. And if the range of tide in question matches with the neap range of, say in this case was 4 meters, so for every curve it shall be mentioned here, so you'll have to see from here. So if our range matches with the neap range, then we shall use the broken line curve, which will be the mean neap curve. Now if our range happens to be something between mean and spring range, then we shall do the interpolation, linear interpolation, and it can be visually done. You don't have to calculate or draw by scale. You can visually interpolate between the neap curve and the spring curve. But if the range in question is higher than the spring range, or the range is lower than the neap range, extrapolation is not allowed. So if the range is higher than the spring range, you will use the spring curve. If the range is lower than the neap range, you will use the neap curve. So you will not neither go outside of the neap curve on the lower side, nor shall you go on the higher side of the spring curve. So you have to please remember that in this case only interpolation between these ranges is allowed. Extrapolation is not allowed. You can read on this side also. Decide the curve on the graph, dotted or the solid line. It's the range of tide which matters and not the time difference. Interpolation can be done between the two curves, but no extrapolation should be done. For ranges higher than the spring curve should be used, and for ranges less than the neap curve should be used. We shall apply whatever we have learnt in calculating times and height of tide at the standard port of ATT Volume 1 through few examples. Calculate the height of tide at Antwerp ATT 1 at 0630 hours on 2nd January 1992. We know that Antwerp is a standard port. Why? Because the video itself is aimed at covering the standard ports in ATT Volume 1. But when it comes in the exams, it may not be mentioned that it's a standard port or a secondary port. So every time we shall carry out the entire process without assuming or presuming rather that the given port is a standard port. So now what shall we do? We shall go to the geographical index of ATT Volume 1. Go to the geographical index of ATT Volume 1. When you go to the geographical index, it's all in alphabetical order. You'll look down for the port of Antwerp, and the port of Antwerp is here. What is written here is this: Antwerp. It is in caps, it is in bold. Other ports here are not in capital letters, nor are they in bold. There are only a couple of ports on this page which are in caps and bold. Now all the ports which are in bold and capital letters are the standard ports in the geographical index. So when you visit the geographical index, and if you find the port you are searching for is listed in capital letters and in bold, that means it's a standard port. Then this port has a number 1539, which we shall learn, we'll use it when we do the secondary port, so it will not be used today. And it's also written here that its predictions are on page 182. So from the geographical index, you have figured out that Antwerp is a standard port. We did not presume Antwerp to be a standard port. We went to the geographical index. From the geographical index, we figured out it's a standard port. We also got the information that the predictions are there on page 182 of ATT Volume 1. So now we go to page 182 of ATT Volume 1, and the page would look somewhat like this. And from here, we pick up the predictions for 2nd January, and these predictions, I've magnified them here. These are the predictions, here are the times, and these are the heights. Obviously, this is the time for high water, this is low water, this is high water, and again low water. So this is how we'll go to use the daily pages to extract information. Now to get the height of tide at 0630 hours, we use the interpolation curve. We use the daily prediction that we just extracted. And what do we see? That 0630 hours shall be falling between 0119 high water and 0801 low water. So our 6:30 time shall be falling between this high water and this low water. So we make a table of somewhat like this. High water 0119 and height is 5.1 meters. Low water is at 0801 hours and its height is 0.8 meters. I'm sure you all know what is the difference between these times called. This is called duration of tide. The duration of tide is 6 hours 42 minutes. And what is this difference called? This is called as range of tide. The range of tide is 4.3 meters. Now we find out that whether our time of interest, that is 6:30 hours, is it before this high water or after high water? I'm sure we'll agree it's after high water. So what is the interval of time in question from high water? So interval from high water is 5 hours 11 minutes after high water. So it's the difference between 6:30 and 0119. So our interval of the time in question is 5 hours 11 minutes after high water. Now we go to this side of the curve here. So first we plot mark of the low water on this lower scale. Low water is 0.8 meters. So we mark off the low water here. And we mark off high water. What is the value of high water? 5.1 meters. We join both these points with a straight line, and this line that we have got, we can call it as the interpolation line. Now we go to the base of this graph. Our interval is 5 hours 11 minutes after high water. We just learned a while back that after high water would be on this plus side. So we go to point where it represents plus 5 hours 11 minutes, and from here we go vertically upwards. Now which curve is to be used, whether we have to use the spring curve or the neap curve? Let's look at the range. Our range is 4.3 meters, spring range is 5.5 meters, neap range is 4 meters. So our range falls in between the two, so we shall be able to interpolate. So we go vertically upward from this point here on the baseline, and we go past the neap curve. So basically, if I draw this straight line up, this line between these two curves shall represent a range of 1.5 meters. We have to go basically 0.3 meters up. So visually we can interpolate, and we can go in between the two curves basis the visual interpolation. Now wherever we end this line, from here we draw a horizontal line and go to the interpolation curve, something like this. So we have gone like this to the interpolation curve. From wherever this horizontal line goes and meets the interpolation curve, we go vertically upward and reach this point here. Now where this line cuts this scale, we read it off on the scale, and that shall be the height of tide at Antwerp at 0630 hours on 2nd January 1992. What we read this is the height of tide at 6:30. This height we find is from this graph as 1.75 meters. So our answer shall be that the height of tide at Antwerp at 0630 hours on 2nd January 1992 is 1.75 meters. With basics having been visited, I think we can now run through a couple of more examples. Find the earliest time after 0600 hours on 3rd March 1992 when the depth of Dover with charted depth as 5.4 meters be 10.3 meters. That means when will the depth be 10.3 meters? At a place where the charted depth happens to be 5.4 meters. So we repeat the first couple of steps. We go to the geographical index of ATT Volume 1, alphabetically arranged, reach Dover, and what do we find? Dover is in caps, capital letters, is in bold, its number is 89. By virtue of being in capitals and bold, Dover is a standard port whose predictions are on page 22. So now we go to page 22 of ATT1 and from page 22 we extract information for 3rd March, which is the date of interest. So here is the predictions for 3rd of March and these are magnified here for us to use. So this is how the first step is completed. So now in this case, we have this interpolation curve for Port of Dover, and if you compare it with what we use for Antwerp, you can see the difference. It's clearly evident. Now required depth is 10.3 meters as per the question here. Now the charted depth at that point is 5.4 meters. So what shall make up for the difference between the charted depth and the required depth? The differential will have to be made up by the height of tide. So to achieve a depth of 10.3 meters, we shall require a height of tide of 4.9 meters. This is the daily prediction which we extracted a while back for 3rd of March. Now we get going with the plotting. But before we get going with the plotting, we need certain more information like the duration of tide, range of tide. So since we want this time after 0600 hours, so if you see this daily prediction, obviously the time we are looking at is the time when the required height of tide shall be 4.9 meters between the low water at 5:43 and high water at 10:41. So these two would be the tides of interest. So we have the low water at 5:43. Height of low water tide is 1.1 meters. We have high water at 10:41 with height being 6 meters. Quickly, please get the duration of the tide. I'm sure you'll agree the duration is 4 hours 58 minutes. Likewise, please do get the range of tide. Range of tide is 4.9 meters. Now, in the previous question, we had the interval because we knew the time and we could start from the baseline and go up and come up to this scale. In this case, we have the height of tide that we would like to have. So in this case, we have a starting point on this scale. So let's draw the interpolation line first. We mark off low water of 1.1 on the lower baseline scale. We mark off high water out here on the upper scale. We join them with a straight line. We get the baseline. Now we identify this required height on this scale of 4.9 meters. So this is the required height of 4.9 meters. We follow the reverse order this time. So from this 4.9, we come vertically down to the interpolation line like this. Now where it hits the interpolation line, from where here we go horizontally to this curve. Now when we go horizontally to this curve, we could stop here on the left side of it, or we could go to the right of it. Now you have to see whether time of occurrence is before high water or after high water. Now we can see it's a flood tide. Why? Because 543 was low water, high water is 1041, so it's flood tide. So the height of tide when it is 4.9 meters, that shall be a time before high water. So that means when we go horizontally from here, we'll be stopping on the left side. That means before high water. So we go to the left up to the curve, and what we find is that there is only one curve here. So the question of interpolation, extrapolation does not arise. So we hit the curve. In this case, it is the spring curve here. So we go and hit here. So don't worry about the range now, because whether it's 5.9 spring here and 4.9 for our case, when there is only one curve, you shall come up to the curve that is there. Now from here, you come vertically down onto the base scale and you read off this interval from here. And the interval happens to be, when you read up from here, it's 1 hour 40 minutes before high water. It's 1 hour 40 minutes before high water. So that means the required height of tide shall be 1 hour 40 minutes before high water, which is at 1041. The interval is now obtained from the plot, and it's 1 hour 40 minutes before high water. And what is the time of high water? 1041. So then what shall be the time when we'll have the required height of tide of 4.9 meters? Obviously that shall be 1041 minus this interval, and the time happens to be 0901 hours. So at 0901 hours, you can expect that height of tide of Dover, where the charted depth is 5.4 meters, would be 4.9 meters, making the depth of water as 10.3 meters. Let's test our understanding through one more example. A vessel at Antwerp, drawing 6 meters forward, 7 meters aft, has to cross a bar marked 3 meters on chart with an underkeel clearance of 1 meter. Find the earliest time she can do so during the rising tide on 7th April 1992. So we shall use some concepts which I am sure all of us are familiar with. What is the maximum draft given in this case? Maximum draft in our case is 7 meters aft. So the maximum draft is 7 meters. What is the desired UKC? Desired UKC is 1 meter. To have a desired UKC of 1 meter, what is the minimum desired depth? Desired depth is then 8 meters. Now, what is the charted depth out on the bar? The charted depth is 3 meters. So if you wish to have a depth of 8 meters at a point where the charted depth is 3 meters, this differential of 5 meters has to be the height of tide, then, as we discussed in the previous case also. So basically now the question translates into as to what will be the time at Antwerp when the height of tide shall be 5 meters on a rising tide on 7th April 1992, and that to the earliest time. So the first flood tide. Rising tide means flood tide, falling tide means ebb tide. This is one part of the calculation that I'm sure all of us are comfortable with. Now we go to the geographical index, which we have discussed in the previous two questions also. Go down, locate Antwerp. We find Antwerp is in capitals and bold. So is a standard port whose predictions are on page 182. We go to page 182. We go to 7th April. Look at the daily predictions, pull out the data, and this is the daily predictions for 7th April. What do we see? We have a low water at 0003 meters, 0003 hours. That means 3 minutes past midnight. And we have a high water at 0537. So obviously this will be a rising tide from midnight onwards, and therefore we can find out what time would be the height of tide 5 meters during this interval of 0003 hours to 0537 hours. So we have the interpolation curve for Antwerp, which we used in one of the earlier examples also. What do we need? We need to find out the earliest time on a rising tide when the height of tide shall be 5 meters. And this is the daily prediction for the date in question. We have already discussed that this our time of interest shall be falling between 0003 hours to 0537 hours. Let's tabulate them in the table that we have used earlier. Low water is at 0003 hours, height being 0.3 meters. High water being 0537 hours, at 0537 hours, height being 6 meters. Duration 5 hours 34 minutes. Range of tide 5.7 meters. Now we go on this side. We draw the interpolation line by first marking off the low water on the lower scale. Low water is 0.3 meters. We mark off high water of 6 meters here. We join them with a straight line. We get the interpolation line. Now we go on this scale and identify the point which represents the desired height of tide, which is 5 meters here. We come vertically down from here and hit the interpolation line. Now from here we have to go horizontally. Now whether to stop to the left of this curve or to go to the right of the curve, we can have a look here. Our time of interest shall be before high water, and since it's before high water, we shall be stopping to the left side of the curve. If it was after high water, we shall go to the right side of the curve. Now we have a look at whether to use the neap curve or the spring curve. Our range is 5.7 meters, which is higher than the spring range. And if you remember, extrapolation is not allowed. If the range happens to be more than spring range, you shall use the spring curve. If the range happens to be less than neap range, then the neap curve has to be used. So in this case, we shall be using the spring curve. So we come to right, horizontally to the right, and we reach the spring curve. Why? Because the spring range is 5.5 meter for the curve. Our range is more than that. Extrapolation is not allowed. Where it hits the spring curve, we come vertically down onto the baseline scale and we read off the interval from here. The interval read from here is 0 hours 57 minutes before high water. If it was on the right of this, then it would be after high water. So we have the interval 0 hours 57 minutes before high water. What is the time of high water? 0537. So then obviously the time that we need would be 0537 minus this interval, and that happens to be 440 hours. So at 0440 hours on 7th April 1992, ship drawing a maximum draft of 7 meters can safely cross a bar where the charted depth is 3 meters with a UKC of 1 meter. With this, we come to end of this video. I hope that our effort is of some value to you. If you have any feedback, please do write to us on marinegurukul@gmail.com. If you like our effort, please do subscribe to the channel. Share your comments on the videos. Share the video amongst your friends who may be in need of it. That's the motivation that we are looking at. Nothing more than that. Thank you very much for watching Marine Gurukul video series. Thanks a lot.